It seems like economics and grafting, they just go hand in hand. So this video is going to be a quick review of many of the concepts of graphs, and not so much how to make them, because most of you know how to make a simple scattergram, but what this is really going to be looking at is how to use them and which types of graphs you use in what circumstances. So in economics, as in other sciences, graphs basically serve two purposes, let's remember. And the first one is that they're sort of a visual communication, and that's one reason why economics uses them so much, this visual communication that we all can agree upon. And second, they're a way for us to be able to interpret the data and to find patterns in that data. Visually, it's much easier to find patterns than it is when just looking at numbers. So let's get to this. The three most popular types of charts out there probably are the pie, the bar, and the time series graph. Now, wait, I can hear you now saying, but I know these, I don't need to listen to this video. Give this just a second or two, because what I really want to make sure is that you understand that each one tells a different stories when it comes to economics. We're using each one in a very different way. So let's just take a look quickly at the pie chart. Now, the thing to remember about pie charts is that they're looking at the whole data set, the entire amount of information we're having, and then we're breaking it down. So it's looking at the whole population. That population might be all the revenue that a company brings in, or all the employees in the company, or it could be how the community uses different resources. The basic thing is, though, it's about the whole and how that whole breaks down. Whereas the bar chart, don't know where that came from. The bar chart is used to compare different data sets. Now, where pie is looking at the whole and wants to understand how that whole is broken up, the bar chart is looking at the differences between these different data sets. Now, it's not concerned with the whole at all. It's only looking for where things may be different. You may be looking for things that are similar, but basically it's looking at differences. That's its big thing. And the last one is the time series graph. Now, some of you may call this a line graph. It's basically the same thing. But in economics, we're usually using this over a period of time. And what we're looking for is what changes may have occurred over that period of time. We call this a tracking kind of chart. We're tracking what's happening and see if we can't find some patterns. So the other thing you may have noticed about all three of these is that they basically are presenting you the exact same data. It's all visual information that's provided to the viewer in different, basically, perspectives. Moreover, all three of these are focused only on one variable. So these tend to show, change over time or across an individual event. Just remember the goal of what each one of these graphs is trying to do and tell you. And as a student, when you're analyzing data and you're trying to communicate, make sure you understand which type of graph you're using and what that type of graph is trying to communicate to you. Now, the big issues with these three is that they can only use a single variable. So we need to use something different when we want to look at two variables. So let's move on to that. More often than not, economists are really interested in multiple variables rather than that single variable we just saw in the other three charts and graphs. We're looking at the relationship between these variables. And often, by the way, that relationship, that spot where the two come together, we call these data points. Now, to find the relationship between these two variables, a coordinate system generally needs to be developed. So that sounds like a lot of mumble jumble. Basically, what we're doing is we're taking two pieces of information, we're finding out where they meet, you might want to say, and we want to see if one affects the other. So does the heat of the day affect how many Slurpees are sold? And that might help 7-Eleven make a decision on how many Slurpee cups they order on certain days. So let's take a look at kind of a silly little graph that I've put together. And this silly little graph is going to be looking at GPA as one of our data points over here, and we're looking at shoe size as our other variable. So basically, maybe if I am a school administrator, I would like to know, if I measure a student's shoe size, can I predict what their GPA is going to be in college? Or if I'm a bookstore manager, maybe if I know the shoe size of the basketball team, I might be able to predict what kind of GPAs they're going to have. I don't know. There are many reasons we might want to know this, but again, it's just a silly example. We do want to remember that this is the y-axis right here, and that this is the x-axis right here. So we have the x and the y. Now the y is also sometimes called the rise, and we'll get more into that in another slide, and the x is often called the run. What we're really looking at here is sort of what used to be called in your high school a scatter plot, and it's still a scatter plot. What we have is a series of points, and those points have coordinates to them. So if we look at this point right here, we have a student who has a size 5 shoe, and their GPA is a 1.5. Whereas if we come out here, we've got a student who's got a size 11 shoe, but their GPA, let's bring it up a little bit more, their GPA is more like a 3.5. Now, the important line that we really want to look at here is this basically green line. What the green line is telling us is basically what we call a trend line. So that green line is saying that, taking all this information together, here is basically the trend of what we see. And in this case, what it's telling us is the smaller the shoe size, the smaller the GPA, and that as shoe sizes go up, basically their GPA goes up. Now, that's really important for us to know because it is basically a predictor for us. We can make predictions based on this trend line. We could look at a specific GPA and make a decision about what the shoe size might be, or if we get somebody with a specific shoe size, we might be able to know what their GPA is. So let's say that we come over here to a size 8 person. We can predict that that size 8 person is probably going to have a 3-point GPA. Now, the problem is with the trend line is that we don't know how strong that trend is. We just see this line. But if we were to add, let's say, this yellow line, now it's not the true trend line for this particular graph, but this yellow line actually shows a stronger relationship between the two variable points we have. So in this case, if we're looking at somebody who has a size 8 shoe, now we're seeing that basically it's going to be a 2.5 GPA. But what's more important is the angle of the line. The angle of this line is much steeper going this way than the green line is going that way. So that steepness tells us that that trend is more likely, or basically one variable really affects the other variable. Now we could also though have a straight line like this pink line. That would tell us that there's no relationship between the two of them. That one thing does not help predict or influence the other aspect of whatever we're looking at. So in this case, GPA and shoe size are not related at all. We couldn't use someone's shoe size to determine their GPA. We couldn't use their GPA to determine their shoe size. And that's probably much more what reality is. But hey, fun videos, little something strange, and you might remember that. But so far what we see is that all of our trend lines have been basically going from the bottom, heading toward the top. Now, those are all called positive trend lines. Now, we like positive trend lines because we see things going up. What's really important to understand about positive trend lines is that basically when this side goes up, this side goes up. So the higher the number we have here, probably the higher the number down here. We like to say is that the variables are moving in the same direction. Now, it could also be true if both variables were going down. So if we go from that down to 1, and we go from here, you're probably going to see on this side that it goes down to 6. So they're trending in the same direction. So that's what variable, so when we talk about the direction of variables, that's what we're talking about. And in this case, we're looking at trend lines to help us understand that both sides are going up or both sides are going down at once. But we could have another type of trend line. We could have one that goes down. So this blue line, and we would call that a negative trend line. Now, what a negative trend line basically says is that when one side goes up, the other side is going to go in the opposite direction. At first, you might want to say, well, that's a bad thing, because a lot of times when people are looking at these charts, they think money. And of course, if we're talking about money, we'd like to see it go up. But there are a lot of times we'd like to see a negative trend line. So let's say we're stimulating an economy. We would hope to see that we would have a trend of basically less unemployment. So we would trend, the higher that we put money in, the less unemployment we would have. And that would create a negative trend line. And that's a line we might want. So what does that mean for us? Well, the big thing here is to understand that the word positive and the word negative do not mean good and bad. What positive and negative only tell us is which direction a line is going. It would depend on what we're measuring on whether or not this is good or bad. Now, in reality, a chart like this might be used to, well, maybe compare countries' productivity rates to the relative size of their population. It's a very common thing to see, but there are even some more common ones that we use in economics. Sometimes we want to measure more than just two variables, and all that's looking at in this chart are the two variables of GPA and shoe size. So what are we going to do when we have three or more variables? So let's go take a look. So as we look at this blank screen for a second, this is sort of how my brain thinks right now, because the truth is that we've been looking at one variable charts and we looked at charts for two variables, but in the real world, economists are always looking at more than two variables. We have three variables at the time we want to look at. And so these 3, 4, 5 variables are going to create all kinds of new types of curves. But at the same point, how do we do that? Well, probably the most popular curve that we're going to see, which is going to look at multiple variables, is going to be called the demand curve. And its cousin, you might say, is the supply curve. Both of these are going to look at the effect of price and quantity. So if there's a change in price, how does that affect the change in the quantity that somebody either wants to buy or the quantity that a producer may want to produce? So let's say that we've got Susie Q here. Susie Q wants to open up a movie theater, and she knows there's this new part of town that's being built, and she's going to build her movie theater there. Now she's got a good friend who lives across town. They own a movie theater, and they've given her this data for Friday night from their movie theater. Now she thinks this is going to be a good set of data to make some assumptions off of, because the new community is going to look a lot like the community that her friend has their movie theater in. But she wants to make a few changes. She, has her own theater. She kind of says, hey, what if I do this or what if I do that? And could an economist help her understand what the effects might be of changing either the price or the quantity? And the answer is yes. But the first thing to understand is that when we look at this chart, we've got three variables. We've got the price as one variable. We've got quantity, which is what these numbers are, as another variable. But we also have income level as a third variable. And so if you looked at our last two charts, they couldn't handle three different types of variables, but this chart is going to. Now, what we are going to do is we're going to make an assumption, and that assumption will hold one of the variables basically constant. Well, price and quantity are not going to be our assumption values. We're going to use those for measurement. We're going to measure against price and we're going to measure against quantity. So what's that third variable going to be? Well, that's going to be income level. And so she has to decide what is going to be the most common income level for her new community that's coming in. And she's told us she thinks that $40,000 is going to be sort of the average income for the household of the community that's being built. So from that, we're able to build her basically a demand curve, and it would look something like this. So what we have is we have price over here on the Y, and we have quantity over here on the X. These are our two basic variables we're going to use to measure. And we've taken this income level of 40, and you can see we have a demand curve of 40,000. That's our constant. And we've taken this information. These became our coordinate pairs. So the number 6 was coordinated with the number 25, and you can see that those data points were put on here. And then we drew sort of basically a line between everything. And this gives us a demand curve. Now, from this demand curve, we can now start making some estimates for her. So maybe one of the things she's thinking about is changing one of the prices to $14. She says, we've got these super digitals right now, and the super digitals are running $16. I wonder what would happen if I decided to charge basically $14 for super digitals. What would the effect be? Well, what she sees is that it would maybe increase the sales of those movie tickets to $15. What we have here is moving along the curve. We're moving up and down this curve to see what the effects is. Now, in this case, we move down the curve because we're talking about reducing the price of the super digitals. But this same data point could be used in another way. What if we were to say, let's go ahead and look at these nighttime prices, and I think $13 is too small. Instead, I'd like to raise that $13 price, the night price, to $14. What would the effect be? Well, I would have 15 sales. Well, right now we have 17 sales, so we're going to lose some sales. And again, we'd have to ask whether or not the loss in sales would equal the basically income increase we would get from increasing the prices. And by the way, vice versa, when we did the super digital one, because we reduced the prices, even though we increased the number of tickets, did we increase the amount of money? So understand that these curves like this, they're basically giving us prediction values, and we can make some assumptions based on them. But what we were doing is we were holding one of the variables constant. We were holding that income level at only $40,000. But she would like to know is what would happen if her prediction of 40,000 isn't correct? What would happen if the income level turned out to be 60,000? Or what would happen if the income level turned out to be 20,000? Could she still use some sort of graph to help her predict what's going to happen? And the answer is yes. It would look more like this. Now, again, notice that we have not changed price and we have not changed quantity. And this line right here is the same one that we have in this chart over here, because that hasn't changed. Just because we have multiple lines on here doesn't mean that that line has changed. But what we do see is that we have two new lines. So the first line is looking at what happens if the income goes up to 60,000. If the income average goes up to 60,000, this curve is going to shift from 40,000 to the right of the original curve, and it's going to shift to this direction. But what if her 40,000 was incorrect and the average income turned out to be 20,000? Well, then we're going to see a shift to the left. And so we might also say this shift goes down. So each one of those variables will change the way that we see this actual curve fall out. Now, that also helps us understand what her possible maximum income could be and what her possible minimum income can be. So we could take the same thing right here at $14 and we could put it here and see what the difference would be here. We could move it out to here, which we already know, or we could move it out to here, which we already know. So it would help her make decisions depending on which income level actually turns out to be. So remember that this first chart over here that we have is taking a look at income level at the assumed 40,000, but this one we have now shifts in demand, because we'd also like to see is what if our assumptions are incorrect and we make the assumption that our average income turns out to only be 20,000 or it turns out to be 60,000. Either way, we're going to be able to use a chart to help us make decisions. This is why this is extremely important and popular. It's really the bigger thing I like students to understand. Very, very popular in economics to use. So you're going to see a lot of supply and demand. All we're doing is shifting things back and forth, and it's based on the data points that we are provided. So earlier in this lecture, I showed you this chart, and I talked a lot about the trend lines, and that the trend lines would tell us basically how strong of a relationship there is. Well, that's true and it's not true. We do know that the angle of the trend line tells us that one trend line was stronger than the other. So the green was moderate, the pink had no trend, the yellow and blue were pretty strongly trended. But we just can't use our gut, you might want to say, to do this. We have to actually have proof. So that's where basically the mathematical part comes in. So we're going to start with our y and our x. And so the y, if you remember, that's called the rise. And the x, if you remember, that's called the run. So we're going to start with those 2 points. The other things that you'll be given is 2 points. Somewhere on this chart, you've got these 2 points. And from that, we're going to be able to determine a couple of numbers. So on the run, this point has a 2, and on the y, we show it's at 8. It has a coordinate pair of 2 and 8. Whereas on the run, the green one is 3, and then we see the 6, and so the coordinate pair is 3 and 6. So what we want to do is to create the slope formula, and the slope formula is pretty easy. It's basically the first coordinate pair minus the second coordinate pair. So we're looking at the y of the first coordinate and the x of the second coordinate pair. So a shortened way to say this is just simply rise over run. The biggest thing with coordinate pairs is to sort of remember and I don't know, it just took me forever when I was a kid to remember this, is that the X goes first in a pair and that the Y is the second number in the pair. The problem is that when you're doing the formula, as far as just remembering things, it's sort of the opposite direction because the Y goes on top. And so when I see people who've made mistakes in this, it's quite often a mistake in putting these numbers into this formula. They'll put the X on the top and they'll put the Y on the bottom. Or they mix up their pairs, meaning is that they have maybe they put this 6 and this 2 together, and that's not correct either. So let's use these two coordinate pairs and set up our formula. So this is basically what it would be. We have the 8 minus 6, so what we've got here is we've got our 8 minus 6 over our 2 minus 3. And so if we work that out, that's pretty simple. We've got this particular answer. So we've got a 2 on the top and a negative 1 on the bottom. And of course, those of you who are quickly saying, well, that's going to be a negative 2 if we simplify it. And that is true. We may not want to simplify it, though, right away for economics, because the negative 1 is going to tell us something. So I do want you to see that you don't have to worry about which direction you do this. What happens if I use the 6-3 coordinate pair first instead of the 8-2 coordinate pair? Well, basically you're going to get the same answer. You're still going to get negative 2. So the nice thing about slope is that you don't have to worry about which pair do I use. You know, is there an order in the pairs? No, what's more important is that you make sure that you have the first coordinate y over the first coordinate x. And that's, again, where I see a majority of students have made mistakes. They understand the formula, they understand the basic concepts, they misput what number goes where. And so here for this, the slope of these two, as we said, is negative 1. Now, this automatically tells you, because it's a negative, that this is going to be a downward slope. We know this from our last slide. Negatives, it means it's going to be a downward slope or a negative slope. A positive slope is going to be going up, and a 0 would tell you that there was no slope at all. So these are, again, 3 basic things that you want to remember when you're looking at what your slope number, because these are going to tell you a lot about which direction basically your information is going to go. So from there, let's take a look at Susie Q. Remember, this was Susie Q's basic line for demand at $40,000 at 40K average income. And so we can actually now know that we've got a downward slope. So we're going to have a slope that's negative. So if you're doing your math and you come out with a positive slope, you know you've done something wrong. You've got to have a negative slope. It's going down. We can visually see that. And so what we're going to do is we're going to look at what the difference is between the 13 and the 17. These are going to be our 2 coordinate pairs. And basically what we're measuring, if we really look at this, is the down, in this case, on the rise side. And so here's where rise always confused me when I was a kid, because you're saying the rise size, and yet this is going down. Well, it's got to go down, and we're going to go over. And we'd like to know what the slope of this angle is right here, because this might help us make predictions in the future for other things. And so we take those 2 coordinate pairs and we go ahead and remember that slope equals rise divided by run, and here's our formula. And so we come out with a negative 3 divided by negative 4, or 3 over 4. Now the negative number is again going to be important because we now know that this is correct because we've got a downward slope. So what does this tell us? Well, if it's a straight line, then all the points on the line are going to have the same slope. And so that's nice. We only need to use 2 sets of numbers then, and we understand all the differences and all of the numbers on the slope. So basically the slope is sort of a ratio. So it's a ratio of negative 3 to 4. So we can estimate for every $3 in price reduction, Susie will sell 4 more tickets. That's sort of what we understand when we look at this. So now we don't have to have this chart. Once we know what the slope is, we could look at 17 and 13 and say, well, if she reduces that to $10, then she's probably going to increase her ticket sales from 17 tickets to 21 tickets. Now, you may right now be stopping and going, wait a minute, what are you talking about? When I look at these numbers, though, 21 tickets is associated with $9. And that's absolutely true, because the saying that we just said is that the slope is the same if there is a straight line. So you're seeing a straight line, but are you seeing a straight line? Well, the truth is you're not. This is actually a little bit of a curved line. If we drew a line through the actual points, notice the line isn't straight. What you were looking at was the trend line. So a straight line that you saw was the trend line. The trend line is not the numbers that we can actually use for determining slope. We have to use the actual points. So the slope that's going to be between these two sets of points is now going to be different than the slope that's used between these 2 points because we actually don't have a straight line. So the truth is in reality, in your economics classes, you're probably not going to have to worry about these little bends and bows because again in economics classes we don't like to go to hard math. We like to make things a little simpler for you because we're more interested in your concepts. But I do want you to notice that in the real world you may not get a straight line. Now I can use that trend line because the trend line is pretty close to what the real line would be, and so we can give us again a good estimate. But that's why economics isn't always an exact about the future, because nobody has a crystal ball. What we can do is give you a good rough estimate of what we're going to see. But the exact, again, there's so many other variables that could be out there. But it is important for you to understand what slope is. Slope is basically this measurement, and it's a ratio. And that's why we didn't just go right to -2 on the other one. We said 2 to 1, meaning is that for every one change there is here, there'll be a change of 2 in the other item. And you're going to see this all the time. So just understand the basics of what a slope line is. Remember sort of rise over run and how to figure out the slope, because more than likely in your real classes you're going to have a straight line. You're not going to have this little wiggle or wobble that you have. I just like to show that there can be wibbles and wobbles because sometimes you have an instructor who is looking for you to understand the reality versus sort of the simulation of economic processes. I'm really not certain if I can really explain or emphasize how important understanding the basics of grafting is when it comes to economics. Sometimes I see students, they go too long before they begin to really express that they didn't understand what the grafting was trying to tell them, or they don't really look at the numbers. But grafting is like the main visual tool that's used in economics, and we use it all the time. So you have to have a kind of a good grounding in what I just talked about in order for you to really find that your economics classes are going to go pretty easily. So I hope this helped. In the meanwhile, till we meet again, keep learning.